Good afternoon, everyone. I'm Joshua Siagar, and I'm here to present my topic titled Civil Engineering Against the COVID-19 Pandemic. So, if you're wondering why there is civil engineering in tackling the pandemic, so if you recall, in public health, there are two components, public and health. So, it has to consider the stakeholders and expert opinions, even from the other fields, even outside of medicine. Whereas in medicine alone, they are more focusing on their specific subtopics, which they call as specialization. The ideal, particularly for COVID-19 pandemic, supposedly, public health should reign supreme above medicine. So, public health is the one that is more inclusive, but in reality, it is the medicine that is currently, how they call this, micromanaging the affairs of public health. uh, that resulted in some bad things. Like in the recent example, during the Omicron surge, there are some MDs that treat Omicron, the more contagious virus, as somehow a ways for natural immunity, so per se, but they have been neglecting the possible viral mutations that can actually surpass or circumvent the effects of the vaccines in the first. Are other questionable takes throughout. We have all gone through this. So, the economy versus public health, that false dichotomy, the militaristic response, the reluctance for mass testing, the minimal contract tracing, poor data handling and projections, and of course, the imposition of face shields. So, uh, nowadays, of course, we're dealing with achieving what's called the new normal. So, achieving that new normal, sadly, across the globe, they've been treating vaccines as the only way out of the pandemic. So that results into what's called the vaccine-only approach. People mistake that vaccines prevent infection. Reality is that the vaccines, to the very least, lessens the severity of symptoms. It doesn't prevent an individual from getting sick in the first place. So, reality is that in order to suppress or stop the COVID-19 pandemic, we shouldn't be even talking about the endemicity. There is a need to control the transmission to prevent further mutations that could, again, uh, result to variants that are vaccine resistant. So, of course, in contrast to first world countries, where there are constant surges that are happening in the Philippines, why are there low cases despite that? It is because of the basic notion of bawal magkasakit. Filipinos in particular, cannot afford to get sick because the financial burden that it will possibly cause. So, in handling about that, particularly in the prevention of transmission of people getting sick, of course, there are some accusations with the MDs calling out other stakeholders or other experts of what's called the epistemic trespassing. So they accuse, for example, aerosol scientists that they are intruding into their field. Reality is that back in 2003, there's this engineering professor named Ugoli who actually contributed to suppressing SARS-CoV-1. Currently, he's also a honorary professor in public health. So he is an engineer, but public health honors him. Why? If he is also included in the World Health Organization COVID-19 IPC. So how on earth does an engineer get themselves involved in such uh, field that supposedly lies in the realm of medicine? So if you recall, back in 2002, 2004, there's this SARS outbreak. So 2002, the outbreak began, and mid 2003, even the CDC back then is already giving up on suppressing the spread of SARS in the Far East. However, uh, that arises actually on the misconception that respiratory diseases like SARS-CoV-1, the SARS epidemic, is mainly, according to them back then, it's mainly transmitted through large droplets or person-to-person contact. That is actually debunked by this super spreader event where uh, the the infection actually jumps from one building to another. So if we're treating large droplets as the main modes of transmission, it can no longer explain why on Earth is this happening. And actually, Dr. Lee actually provided that explanation, telling that in the first place, respiratory diseases are airborne. So we need to draw a distinction between the expertise concerning COVID-19. So as engineers, lies on the aerosol physics and engineering perspective. So the modes of transmission follows the laws of physics. Therefore, us who understand those laws should have a take or have a contribution in preventing the transmissions themselves. Whereas if we're talking about clinical expertise, so once a virus enters the body, how the body reacts, it's their take. The MDs can take it. So it's called clinical expertise. However, during the COVID-19 pandemic, just recently, the WHO, the World Health Organization, is actually telling everybody, stamping its feet, telling that no, COVID-19 is not airborne. It's supposed to be transmitted through droplets. So those spray, those projectile droplets. And it is actually the assertion that is passed over to the OH who asserted the same thing in defense to their face shield mandate. So of course, it takes a collaboration between aerosol scientists, mechanical engineers, and public health experts to actually gather evidences which they sum up into 10. So there are 10 scientific reasons that actually support airborne transmission and actually diminishes the merit of even considering droplet transmissions in the first place. So they listed a total of 10. One of the one of the people involved in gathering those evidences, Professor Jose Luis Jimenez, actually presented here in the University of the Philippines, detailing what to do, the science behind and the science behind airborne transmissions. And you can actually access the recordings and the PowerPoint presentations of the said webinar in the links below. One of the highlights of his webinar is telling that surface transmissions or simply getting infected by touching surfaces is not actually consequential or not actually a thing. So it is minor at best. So we shouldn't be obsessing ourselves in disinfecting every surfaces that we touch or our hands from time to time. We should be focusing more on the air that we breathe. So we need to protect ourselves from those suspended aerosols, those airborne pathogens, which include, of course, COVID-19. And one of his main dictum is that for droplets and surfaces, it is very convenient for the people in power because the responsibility lies on the individual alone. So they are tasked to, for example, install barriers, put on face shields, put on face masks, disinfect every surfaces. But on the other hand, if you get to admit the reality of COVID-19 being airborne, institutions, governments, and companies have to do something. So, of course, as civil engineers, of course, have a role in fulfilling that dictum. First is, of course, to communicate that the natural phenomena that we tend to observe and tackle as civil engineers are also consistent in terms of physics when compared to how viruses being transported across space. So, for example, the viral transport is similar to mechanisms of uh, sediment transport, where the virus tend to linger more or accumulate more in regions where the flow of air is still. So if we compare that to the river, so sediments tend to accumulate in the portions of the river where water is still. On the other hand, of course, with regards to face shield, so there's this thing called street canyon vortex effect, where aerosols tend to accumulate in the regions that is being sandwiched by two black bodies. So in response to that, so the face shield, of course, it is also consistent to what's happening in face shield. So aerosols accumulate in the region between the face and the face shield. So it is the main reason on why face shields are actually dangerous in the context of airborne transmission. Of course, finally, as civil engineers, since our concern is buildings, so we have to ensure that the buildings that we are designing are designed against COVID-19 transmission. So those buildings can be called as healthy buildings. So we should put that into consideration. So what constitutes a healthy building? Of course, when recommending the things that comprise a healthy building, we have to understand the modes of transmission. So first of all, sporadic emission. So aerosols are more concentrated near the source. The emissions have a momentum, and aerosols are more concentrated uh, near the source. Therefore, that is the reason why social distancing matters. So it is to allow the emissions to dilute themselves as it travel across space. Of course, that momentum in the first place and the concentration is being suppressed by the mere fact that you're wearing a face mask, which stops momentum and actually filters most of the infectious aerosols that can be introduced into the air. Of course, there are still considerations when selecting face masks in the first place. So one must consider the quality of filtration, the goodness of fit, and the breathability. Wearing masks muffles speech, resulting to inaudibility. So to mitigate that, sometimes people tend to raise their voice, which actually introduces more infectious aerosols. So to nip that problem in the bud in the first place, so it is better to equip people with microphone to address those issues. So particularly in doing face-to-face classes in particular. As mentioned, with the momentum gun, the remaining concerns are the aerosols that are floating in the air, invisible to the eye. So it is unknown to you whether you are breathing in infectious aerosols. That's why everyone should mask up as their last line of defense. And it is indeed a strong line of defense if you're wearing the face mask, satisfying the three criteria that I've been mentioning. So there are key clarifications that have to be made. So the goal is to reduce the exposure to SARS-CoV-2, which is done through what's called dilution. Dilution is a combination of filtration, ventilation, and viral deactivation. It particularly addresses shared room air transmission, so that the one that is accumulating in the room over longer periods of time. Ventilation pertains to the opening of windows to prevent aerosols from building up. Uh, Ventilation, of course, introduces fresh air, which is indicated by CO2 levels. Outlined are the steps to determine the ventilation rate in using CO2 monitor. So first step is to measure the CO2 levels of outdoor air. Then, of course, you take measurements in order to determine the volume of the room. You should count the number of test occupants within, determine the CO2 levels now of the indoor air within that room, for example, after 10 minutes, then determine the ventilation rate based on the indoor CO2 levels. So judging on the current CO2 levels that 10 minutes, you can actually determine how fast is the fresh air being introduced to the room. And here is the lookup table to determine the safe occupancy within a room with a certain size and a given ventilation rate. So for example, if you're dealing with that size classroom, so that's about 7 times 8, so 56 square meters. So if we refer to the table, so floor area supposedly between 55 and 60, and if, for example, we aim to have a safe occupancy, for example, of 21 students, so that in our 21 people, so the ventilation rate should reach, so if we're, for example, 23, so over 21, the ventilation rate should exceed, should reach the target of 7 air changes per hour. So that's how you calibrate the ventilation in order to reduce the risk. So if there's not enough ambient wind or atmospheric difference to mechanically facilitate the exchange of indoor air and outdoor environment, it's better to install exhaust fan to uh, mechanically facilitate that. So I just repeated that. Exhaust fans, on the other hand, also introduces what's called pressure diffusion, which draws airborne pathogens uh, that lingers in the air to the exhaust fan, so away from the inhabitants. Mhm. This is one of our ongoing studies which determines where infectious aerosols tend to accumulate within a room over time. So this is a standard DepEd classroom. So if you're simply opening the windows, uh, as we'll observe, the aerosols actually accumulate at the center portion of the room. So that portion here remains red. Therefore, you have to install fans to steer the air, or perhaps expel that contaminated portion there. Of course, filtration is then the next option, which can be installed to aircon units if ventilation is not an option, particularly for closed windows. For example, there's no HVAC systems installed, so it's better to simply filter the recirculating air within. In air-conditioned environments, of course, apart from installing filters on the aircon itself, we should also so in air purifiers, there's a compilation by Professor May T. Lim of the National Institute of Physics detailing which among the air purifiers are the most economical or the most optimal, of course. But there's a cheap alternative that's called the Corsi-Rosenthal box. So it is a DIY filtration device that is efficient and economical. It would require MERV 13 filters, a box fan, a cardboard shroud, and do some duct tape, and voila, you have your course. Well, of course, schools can participate, make an activity in making course rental boxes. So this is the recent activity that we've conducted. So this was about 3 weeks ago. So we procured some MERV 13 filters. Of course, there's exhaust fan, and some students from the UP Chemical Engineering Society uh, actually participated in this activity in making two Corsi Rosenthal box. So it is the first in the Philippines. So I'm proud to say that, of course. So we completed two boxes in total, and hopefully the students are hoping for a safe return face-to-face classes, of course. So Corsi Rosenthal boxes facilitates filtration and upwelling of aerosols to the upper room, and the targets can be determined using the empirical study by Peng and Jimenez. So using the box model here, and here is the relationship between the risk parameter and the probability of infection. It uses the concentration equation to complicate it to detail, but of course we'll just skim through the slide. Uh, I provided a computation worksheet on which you can work on in determining whether the current setup or the current ventilation rate or the current dilution rate within that room is enough to prevent or to mitigate the risk posed by COVID-19. So first of all, in the program itself, you input the number of people, plug in the number of people typically present within that room, determine the total volume of the room again, uh, plug in RSS, which is the ratio between the steady state condition and the exposure over shorter durations, but we leave this value as is, so as it is on the worksheet itself. R sub B is the breathing ratio, which is uh, which actually reflects to the degree of vocalization across occupants. So if occupants are only breathing, we set that value to be equal to 1. If speaking, 1.5. If coughing, 100. F sub O and F sub I are actually the outward and inward efficiency offered by face masks. So if, for example, N95 masks are used, so a factor of 0.05%, 0.05 is considered. If surgical mask, 0.35, if there are no masks, as is. So also we indicate a duration of space as stay inside the indoor space, and we can adjust the ventilation rate accordingly. That would result to the number of infected people to be equal or less than 1. The upper room air, where the aerosols are directed to by the Corsi-Rosenthal boxes, and the buoyancy coming from the emissions themselves are subjected to the upper room uh, ultraviolet germicidal radiation to deactivate the viruses. Of course, install an HVAC system if necessary. But the best case scenario, if there's rigorous contact tracings, of course, apart from engineering controls, there should be administrative controls. So if there's an infected person, should stop that infected person to getting to that building in the first place. So you can eliminate the risk by simply stopping the symptomatic people from entering the indoor spaces in the first place. And of course, it is greatly acknowledged or greatly encouraged to conduct activities outdoors as of the moment. And I think that's all. There's pahimakas. I think the White House actually acknowledges uh, that COVID-19 is being transmitted through aerosol. So COVID, the White House acknowledges that COVID is airborne. Hopefully, we can pressure the government into acknowledging the same thing. Of course, that is our role as the citizen, not only as civil engineers, but also citizens, loving citizens of our country. And with that, I end my presentation. I thank you very much.